welcome to Office Hours for June of 2022. I'm Russ Lowenthal, Senior Director for Database Security Product Management here at Oracle. And this month's topic is database user profiles. Database user profiles aren't something that's new. They've been around in Oracle for decades, but they are really foundational if you are using username and password to authenticate your users. Without a good, strong database profile, then there is always a gap that your other security controls may not be able to cover. Before we get into profiles, though, just a few quick announcements. First one is CloudWorld. CloudWorld's coming up the 16th through the 20th of October. This year it'll be in Las Vegas. For those who haven't already run into this, CloudWorld is what was formerly called Open World. And if you have an interesting database security story that you would like to share at CloudWorld, please reach out to me and let me know. I get to pick a couple of stories for people that want to tell them at CloudWorld, and if your story is selected, then I would be able to get you a complimentary full conference pass to the event. There are a few topics that we're especially interested in. DataSafe is always interesting. Database auditing, stories that relate to the new capabilities around autonomous database identity integration, particularly with Azure AD or with Oracle Cloud's identity and access management capabilities. Key Vault, Database Vault, projects where you are doing a complete overhaul of database security, maybe driving towards maximum security architecture, or maybe in support of a zero trust project. These are all interesting to me. And again, if you have a security story and you're able to travel to CloudWorld, I can't pay for your travel, obviously, but I could get you, if your story is selected, I could get you a complimentary speaker pass. So just reach out and let me know. Next one I kind of already let out of the bag, and that is this month we're happy to announce that Autonomous Database is now able to leverage Azure Active Directory OAuth 2 single sign-on tokens. This initial release of this capability is only Autonomous Database. Over time, you'll see it spread to other versions of the database, but right now it's only Autonomous. But what this means is if you're working in a hybrid cloud environment, and so many of us are these days, and you're using Azure AD is extremely popular, then you now have the option of leveraging those identities both for authentication and authorization. We can leverage the roles in Azure AD as well. Moving on from Azure AD, Key Vault. Our product manager for Key Vault, Peter Wall, has released a new video that walks you through how to deploy Key Vault in OCI and how to add nodes to an existing cluster and just really how to expand your Key Vault clusters with just minutes of work. You can see the URL for this video here on screen for you, but just a really good new asset to work with. If you are a user of Oracle DataSafe, and it doesn't matter whether you're using DataSafe at no cost to monitor your databases in the Oracle Cloud, or if you are subscribing to DataSafe to monitor your databases on premises, then you are probably aware that DataSafe includes, for every database that you monitor, up to 1 million audit records per month per database. Now, very few of our customers ever exceed that limit, but if you generate a lot of audit data and you're worried about reaching your limit, then we have now published a new event in the Oracle Cloud called basically letting you know that your DataSafe is reaching its audit collection free limit and giving you a warning when you are at 80% of that free allocation. That's 800,000 audit records within a single month. At that point, you get a choice. You can either choose to allow DataSafe to continue to collect audit records to go above the free limit, or you can choose to allow the limit to come into place, at which point audit collection will stop for the month, and you'll begin collecting again next month when you get your next free allocation of another 1 million records. All right. In the support corner, there's 3 notes I want to point out. One of them is 283.8877.1. This is our note on the Oracle database and Apache Log4j. This note continues to evolve. If you still have concerns about the Log4j issues that surfaced during the winter or the latter part of last year, please take a look at this. We do keep it updated. And the next 2 are 273.4603.1 and 100.5119.6. The first one is just frequently asked questions about database user profiles. That's this month's topic. The next one is kind of interesting. It is a note that was written for Oracle 7. That's how old profiles are, but is still relevant today, and it deals with why user profile limits might be ignored. We'll talk more about that as we go on. We've had a few blogs that have come out in the last month. You can see those listed here. Visit us at blogs.oracle.com/cloud security to see what's new. We'll be releasing a new blog on the Azure AD integration sometime here within the next few days. That's it for announcement. Let's get to the main purpose of this month, and that is we're going to talk about database user profiles. Let's start with what a user profile is. A profile gets used for a lot of things in Oracle, and that's not unusual that words get overloaded. But when I'm talking about user profiles, it's not a SQL profile, completely different thing. It's not the profile that you see for connections in database firewall, again, completely different thing. Not a behavioral profile. No, when I say user profile, I am talking about a database object that is basically a named set of limits on database resources and passwords. Now, even though we split these up and we say there are resource limits and password limits, don't let the names fool you, because it doesn't matter whether it's a resource limit or a password limit. These all have some impact on security. In general, we think of resource limits as ways to reduce the impact of a denial of service attack or reduce the impact of user errors. People forgetting to log out at the end of the day, people running queries that try and grab all of the CPU or cause massive I/O issues in the database come to mind. Password limits are a little bit easier to understand because as security professionals, we think about those all the time. These are ways that you're able to control what passwords are acceptable, how long those passwords are allowed to be used, and control the behavior of what happens when someone issues a false password trying to log in. Within resource limits, the types of limits you can put into place are sessions per user, which is just what it sounds like. Can the user have 1 session, 2 sessions, 3 sessions? How many concurrent sessions, same time, can a single database account have? Connect time. Once they log in, how long can they stay connected for before the database automatically logs them out? Idle time. If they are not doing anything, no keystrokes are coming across, when do we log them out? Do we say they can have 15 minutes of idle time, 5 minutes of idle time, an unlimited amount of idle time? How much CPU can they consume? And that can either be done per second, or per session, or per call. How many data blocks are they allowed to read? And again, that can be done in their entire session or per call. How much memory are they allowed to consume? If they're doing large joins, something like that, how much can they consume? Bytes, kilobytes, megabytes, your choice. And composite limit, which is measured in service units. We'll talk more about that here in just a few minutes. On the other side of the house, for password limits, we have failed login attempts. How many times can a user try to log in before their account is locked and they can't try to log in again until someone unlocks it? How long, in active account time, how long can a user have an account, not log in, and the account remain active? They can still log in. Are you going to say if they haven't logged in 30 days, they don't get to log into the database without checking with somebody? Or are you going to say maybe they can go for a year, and if they don't log in a year, we're going to do something and like lock their account? How long can they be inactive? Password verification function. This one is really important. We use functions to determine the complexity, or to check the complexity, I should say, of passwords that are submitted to change someone's password. What passwords are you going to allow? What types of passwords are you going to reject? When someone changes a password, how long is that new password good for, their password lifetime? And once they reach the end of that lifetime, how long do they have before their account is no longer able to log in, at which point their password is completely gone? They've reached the grace time, or they've extended their grace time. Are they allowed to reuse a password that has been used in the past? And that can either be, you have to have 20 new passwords before you can reuse a password, or you can't reuse a password that you've used within the last 2 years. You can do that by number of passwords or by days. And our newest limit, password rollover time, which is how long, when you change someone's password, how long is their old password good for before only their new password is acceptable? Now, a database can have many different profiles, lots and lots of different profiles. Every profile can have as little as 0 users assigned to it, or as many as all of the users assigned to it. Every user is assigned to one and only one profile. And if a user is not explicitly assigned to a profile, then they are automatically assigned to the default profile. Good with me so far? Okay. Now, there is a default profile, and that default profile defines all limits. Everything that I covered on that previous slide where we had the resource limits and the password limits, those are all defined in the default profile. Other profiles inherit from the default profile. So if you create a new profile, the only things that you have to put in the new profile are the things that you want to be different from the default. If in the example you see here, I have failed login attempt set to 10 in the default profile, and I override that with failed login attempt set to 3 in the DBA profile, a user who is assigned to the DBA profile can only log in 3 times. All right. Now suppose I have sessions per user set to 2 in the default profile. I didn't set that in the DBA profile, so a user who is assigned to the DBA profile will be limited to 2 sessions per user. If I go out and update the default profile and move sessions per user to 4, then users assigned to the DBA profile automatically inherit sessions per user equals 4 the next time they log in. Okay, so there is this inheritance model. Now, whenever you see something that has like a default profile in Oracle, the question that almost always comes to your mind is, can I change those defaults? And yes, you can. Your changes are changes that you want to impact all users. So if you change something in that default profile, every profile that doesn't explicitly override that default will inherit that change. Remember when I talked about composite limits? I wanted to talk just a little bit more about it, not because you're likely to ever use it. This is old technology and there's way better ways of doing things in Oracle, but because it's kind of cool to think here in 2022 about how we were looking at things back in the mid-90s and of course earlier. So if you go back to the mid-90s, compute resources were a lot more expensive. Disk space, very expensive. Memory, incredibly expensive. CPU cycles, there weren't that many to go around. We didn't have exadatas back then. All right, so at that time, we needed to provide Oracle's customers a way to control how much in terms of those scarce server resources that a session or a user could consume. And so we did that with those resource limit profile options. Well, composite limit was a way to say, I don't want to figure out exactly how many logical reads or how much memory someone's going to use. I'm just going to pick a number, and that number is going to be my limit. And what I'll do is I'll calculate the sum of CPU and logical reads per session, how long they've been connected, how much memory they're consuming, and I'll apply a weighting factor to those and use that to determine what their current state is versus what they're allowed to do. When they've consumed everything they're allowed to do, that's it, they can't do anything else, they have to establish a new session. All right, today we wouldn't do this. Today we would use Resource Manager, which gives you way better control over resource limits. But this is still there in the database because sometimes it's still valuable. Now the cool thing is, this is ancient stuff, but we provided you a way to set your own weighting factors. You didn't have to depend on our algorithm. So if in your server, memory was a little bit more important than CPU, you could set private SGA to a higher weighting factor than, say, logical reads per session. Okay, or CPU per session. You had control over these. Really cool to see how this evolved. Again, composite limit, you're really unlikely to use this in today's world. Okay. The other one I want to talk a little bit about is password rollover time. This was a new feature in Database 21C. We backported it to our current long-term release, 19C, with the July release update last year. So if your database version is 19.12 or higher, that was the July update, then you have the ability to do password rollover time. If you'd like to learn more about password rollover, take a look at the recording from the August session last year, where we devoted the entire session to this new feature. But the executive summary of it is, I have a database account. I changed that database account's password. It's got a new password now. For the length of time set in password rollover time, the new password works and the old password works. When the length of time set in password rollover time is reached, the old password no longer works and only the new password works. This was intended to give you a safer way to rotate service account credentials. So you could change the password in the database. Nothing is changed out there for those things that are using those credentials to log into the database. And then at your leisure, you go update those credentials in batch files, application property files, secrets managers, however you're getting your applications to log in. And when they're all done, that's fine. You let the password expire, the old password, or you can manually expire it. All right, again, if you want to learn more about this, everything from how do you audit which password is being used to how you manually expire them, take a look at that August 2021 session. Okay. Now we want to talk a little bit about assessing profiles. And here what we're looking at is how do you see what profiles you have, how are the settings for those profiles, and what are things you should look for. For this, we could use any of two different tools. We could use the Database Security Assessment tool, or we could use DataSafe. I'm going to go ahead and use DataSafe. It's a little bit more of a graphic environment, a little prettier, and it's just got some nice things to look for. So we'll log into DataSafe, and we will go to Oracle Database. You probably saw I had it pinned on my home screen, but we'll pretend I didn't. We'll go to Oracle Database. We'll go to Security Center. And the first thing we're going to look for in Security Center is user assessment. And when we look at user assessment, we can go to Target Summary. We'll pick one of our databases. Let's just give it a second to come up here and view the report. And we see a list of the users that are in our database. Now, by default, the profile doesn't show in this list, but we can manage columns. Let's just get rid of a few that we don't care about. And we'll add in user profile. And we can see for all of our users which profile are they assigned to. In this case, everyone's assigned to the default. This is just a test instance, okay? So this is one place in DataSafe to look at profiles, and user assessment tells you which profile a user is associated with. If you didn't want to change your screen like I just did, you could also just click on a user and it would tell you here what the user profile is. All right. The other place to assess your user profiles is in Security Assessment. And again, we'll pick our database, we'll view a report. Now we're viewing the Security Assessment report. And what we're going to look for are user profiles. We can expand user profiles and see every profile in the database along with every setting in the database. Now, when I say every setting, it's not really every setting. Notice we don't have the CPU limits or the logical reads or the private SGA. These are the settings that most people care about with today's profiles, not the resource management stuff that is seldom used. All right, so we can see what profiles I have, what are the settings for those profiles. We can also see where do we have settings in our profiles and what users those apply to that are weak. Probably one of the most important is account locking after failed logon attempts. Now here we have this listed as a medium risk. This is probably about as high a medium as you can get, because if you have users, as I do, with unlimited numbers of failed login attempts, what this means is someone trying to break in as that user can try to log in, fail, try another password, try to log in, fail. Try another password, try to log in and fail. And you can do that an infinite number of times. In other words, you can brute force that account. And in most cases, a brute force attack is going to succeed eventually, unless your passwords are very strong, very long, very strong, or unless you happen to be auditing logins and happen to notice that this user is someone's trying to brute force into there. So this is a medium finding, but medium high, all right? If you're going to have people whose accounts lock after a certain number of failed logins. Another thing you see here is password lock time. If someone reaches the point where they've locked their account because of too many failed logins, are you going to allow that account to automatically unlock, or are you going to have to manually unlock it for them? If I have no minimum lock time, then what that means is if my account locks, someone has to go in and issue the alter username account unlock statement in order to unlock it. So this is manual. If you set a time, then after that time has expired, the account will automatically unlock without DBA intervention, and the user can continue on. Let's move on to verification functions. Hugely important. Verification functions control the complexity of the passwords that are acceptable to the database. So which profiles have a password verification function, which profiles do not have a password verification function, and if they do have a function, is it one of the ones that Oracle has shipped, for example the Stig verify function, or is it a custom password? And which users are assigned to profiles that have no password verification function, which means their password can be very, very weak. So if you're a user named Bob and your password is Bob, there's a good chance you're assigned to a profile without a verification function. The next thing we want to look at from a profile standpoint is we'll skip over sample schemas and we'll go to inactive users. Which users are assigned to profiles that don't limit how long they can remain inactive without their account being locked. Okay? If an account is no longer in use, that increases the chances that someone could try and hack that account. Maybe they've left the company, who knows? So how do you want to handle that case? How many concurrent sessions can a single account have? Now notice this is a low risk thing, but if you have an account that has a lot of concurrent sessions, usually one of two things are going on. It's either a service account, maybe used by an application connection pool, in which case you would expect that same account to have a lot of connections to it, or it's a shared account. And shared accounts are evil from a security standpoint because it's really hard to attribute things done in a shared account to the actual person who did them. The last thing we look at from a profile standpoint is users whose passwords never expire. Again, this is a low risk finding because some security experts will tell you you shouldn't be expiring passwords at all because that encourages people to write down their passwords. You want to have strong password policies and have your users maintain those. So that's it for profile assessment. Now, I'm often asked in terms of recommendations, what do I recommend for your profile? I like to split it up into two classes of users, and the recommendations I'm going to give you are just that. They're starting points for what you should choose. Don't take this as Oracle says you must have exactly these settings for these types of users. These are just good, reasonable policies to start with, and you should customize these to meet your needs. But here's what I like to do. For interactive accounts, these are accounts where some human being is logging in. In most cases, I want them limited to a certain number of sessions. That might be 2, that might be 3, that might be 4, but it's usually not unlimited. I want to discourage account sharing. I want to make sure that the same user isn't logging in 1,000 different times. I'll normally set a limitation on how long someone is able to be connected to the database before their account is automatically logged out. Not locked, just logged out. This is to prevent somebody from logging into the database and then maybe walking away from their desktop at the end of the day and just staying logged in. We log them out so that they don't keep using resources, and so that that session isn't there if someone's able to break into their workstation. Same thing with idle time, and you've seen this in a lot of your IT systems. If somebody has a connection open to the database and it's sitting idle, no keystrokes, nothing's happening, and they walk away and they come back 15 minutes later, should they have to relog in? If they come back 30 minutes later, should they have to relog in? Or maybe do you want them to stay there forever and never have to log in? Remember, these are starting points, and you can customize them to meet your needs, and it's not one size has to fit all. You can have a profile for certain types of users that needs certain capabilities, another one for different types of users, okay? I don't normally set CPU and logical reads and private SGA or composite limit. That's better done with Resource Manager, but they're still there if I need them. All right, for failed login attempts for interactive users, 5, because people type in the wrong password. I do this all the time. I tend to choose really complex password, and I'm a terrible typist. And when I do make a mistake, I usually make it a couple of times before I realize, oh, I left caps lock on, or I did something stupid like that. So I don't want to be locking people's account willy-nilly. For password lifetime, I'm going to go by whatever my organizational standards are. If it's going to be you reset your password every 90 days, that's what I'll set it to. If it's every 60 days, if it's unlimited, I'll do whatever the organization says to do. For password reuse time, I can either choose time-based or number-based. I'll usually just go with number-based rather than time, and I'll make it large enough, 20, that someone is unlikely to just cycle through passwords trying to get back to the same password they were using before. If someone does lock their account, I want to set password lock time to some reasonable number. And here's how I determine a reasonable number. If somebody locks their account, I don't want them to be able to right away try again with another set of 5 passwords. But I also don't want them to have to call me to unlock their account. I want it to automatically unlock after sufficient time. That could be 30 minutes, that could be an hour, that could be 15 minutes. What you're really trying to do with the combination of failed login attempts and password lock time is balance the risk of someone trying to brute force attack with the operational risk of users who lock their accounts taking up your time to unlock them, okay? Password grace time, I'll normally set that to unlimited. When somebody expires their password, I'm going to expire their password. They don't need a grace time. Inactive account time, whatever your organization's standards are, 30 days is not a bad place to start. Always have a password verify function. And then password rollover time for interactive accounts. I don't need 2 passwords working at the same time. When someone changes their password, that's it. That's their new password. Maybe they've changed it because their old password was compromised. So don't have a rollover. Now let's move on to service accounts. For sessions per user, it's going to depend on the use case. If this is an application service account, that might be unlimited, right? Because maybe it's doing a connection pool and I want it to have as many sessions as it needs. If it is a batch process that I'm running through a cron job, it might be set to 1, because that should never have more than 1, and that's fine. Connect time, idle time, I usually make those unlimited and let the batch process or the application handle that. On the password side of things, failed login attempts, I'll move this down lower than the interactive accounts, because batch processes shouldn't issue bad passwords, right? That's either coded in, hopefully not, or it's retrieving it from a secrets manager, or it's looking at a properties file. But failed login attempts shouldn't happen. So 3 is even high. I might go with 2 or 1 even, but it's going to be a lower number. Password lifetime, I like to make it unlimited. And you may say, this opens you up to someone trying to use a password forever and never change it. And here's what I would say with that. I do want to follow my organization's standards for password rotation, but I don't want my database to take down an application because something happened and I didn't get around to updating the application servers. I would much rather reschedule it for a week later and then go make the password change and update everything without having any downtime. So I'll normally set my lifetime to unlimited. Reuse, I'll set the same way I do for other users. Lock time, service accounts shouldn't lock, right? No one should be issuing a bad password for a service account. So when that happens, I want to have time to go investigate. I might set that to 12 hours. I might set that to a day, but I'm going to set it to some longer amount of time for me to investigate why did this account that should only be used for this application pool or for this cron job, why is someone issuing a failed logins there? Shouldn't happen. Same verify function. I want it to be a strong verification. And here I will use password rollover, and I want to make this longer than I think it would take me to update every service or application server that is using this service account when I rotate the passwords. So 3 days would actually be low. I might make it 5, I might make it 10, I might make it 30. But the idea is I want to have long enough to go out and get everything updated without causing any downtime because I've rotated credentials. All right. That's really it for password profiles. If you'd like to learn more about them, the Database Security Guide discusses them. That's at docs.oracle.com/database. The SQL language reference is a really great place to find information about the different options. It's not just syntax. Look at the description of it, particularly for things like composite limits and alter resource cost commands. This is where some of that historical information comes from. If you're working with live labs, and hopefully you are, both the security assessment portion of the DataSafe lab and the database security assessment tool will give you some tips on assessing your profiles. And if you look back in the archives for office hours, we did a session on passwords back in January of 2020 that's still relevant. Just last year, when we first introduced gradual database password rollover, we did a session on that. And way back in recorded history, July of 2019, we talked about database authentication. This one, kind of a little bit long in the tooth. It's all still valid, but I need to update it. I'm going to check with Rich, who's running the office hours now, and see if I can't get on the schedule for later this year to update authentication. All right, that's it. Before I turn to Q&A, I just want to thank you for giving me some of your time. Don't forget, if you have database stories that you would be willing to tell at CloudWorld, interesting database security stories that you'd be willing to tell at CloudWorld, please reach out to me. I'd love to try and get you a free pass and get you up on stage. Thanks. Take care.